Today we're going to be going through how to graph inequalities that involve two variables, linear inequalities. You'll notice here I already have the steps written down, so we're going to work through the steps as we do these problems. These can be very difficult if you don't follow the steps, so just take your time with it. It's going to take a little time to get used to, but once you get the hang of it, I think you'll find it's not as bad as it seems. Alright, so we're going to start out with our very first step here. Our very first step when we are graphing a linear inequality involves two variables. Get y alone using inverse operations. What does that mean? Well, if you look over here for our example, we see y is already alone, so we don't have to do this step. Now, say y wasn't alone. Say you had something like this. If you had something like that, you would definitely want to use inverse operations to get y alone. You could subtract 2x on each side, and then you would end up with y is less than or equal to negative 2x plus 3. That's what you ultimately want this to look like. You want y to be all alone. Now, again, for our first example here, we're pretty darn lucky. We're starting out with y all by itself. But just be mindful of that. You always want y all alone. So that's the first step. Second step. This is going to be just like graphing a line like you've been doing. First step you want to do is graph your y-intercept. So let's take a look here. We have y is greater than 1/2 x plus 1. Now, if this were an equal sign, it'd be one of those typical linear equations we'd be graphing. It's the same principle. So I'm going to look here. I'm going to look for my y-intercept. I have 1. So I'm going to go to my graph here, and I'm going to graph my y-intercept right here at positive 1. All right, done with step 2. My second step, use your slope to graph at least one more point. Now, ideally, it's good to graph more than 1 point, but we're just going to aim for 1 here. So now what I'm going to do is I'll use a different color to keep this coded a little bit. So I've got 1/2 as my slope. 1 over 2. Remember, it's change in y over change in x. I'm going to go over here. Now, what that tells me is I'm going to go up 1, and then I'm going to go over 2. And that's going to give me my second point. Now, ideally, it's not a bad idea to do a couple of them. So I'm going to go, again, I'm going to go up 1, over 2. I've got a third point here. I like this. Maybe I'll do one more. Why not, right? Again, I'm going to go up 1, over 2. And now I've got 4 points. This is really good. I can get a nice solid line out of this. So you don't necessarily have to write the, going up 1 over 2. As a matter of fact, I'm going to get rid of those just so I have a little less to deal with here. But that's always a good way to kind of help yourself to make sure you're getting your points where they need to be. So let's see. I've gotten y alone. I've graphed my y-intercept. I've used my slope to graph 3 more points. Now it's telling me graph a line. Now, here is what you want to bear in mind. If your inequality is underlined, like if it's an or equal to, you're going to use a solid line. If not, you're going to use a dashed line. Let's take a look here. In this case, it is not underlined. It's just y is greater than 1/2 x plus 1. So since, excuse me, it is not underlined, I'm going to go with dashes. So I'm going to go, oh, there we go. I'm going to make a dashed line here, something like this. We'll go over what a solid line looks like too in a bit. We'll go over an example with one of those. But now I've got myself a dashed line. So now my fifth step, and this is the one that's tricky. You have a couple of choices here. You're going to shade using one of the following methods. Choice 1. It's telling you if y is less than or your expression is greater than y, you're going to shade below the line. And you'll notice we have a few examples here. We have y is less than or equal to x plus 2. You will notice that we colored below our line, below it, right here. We shaded everything below it. In this case, we had negative x plus 4 is greater than y. So let's see, since y is less in this case, we shaded everything below. That's one way you can approach this. So if we look here, I see y is greater than 1/2 plus x. I'm not getting less than here. So let's see what happens here. If y is greater than, or your expression is less than y, you're going to shade above the line. So in this case, I'm going to fix that. Y is greater than x plus 2, or negative x plus 4 is less than y, we shade above. This helps some people. Sometimes people look at this and they're like, I don't know, this choice doesn't really do well for me. But we're going to go over another way you can do this. But in this case, let's take a look. Y is greater than 1/2 x plus 1. That means if it's greater, we want everything above our line. Everything above this, it's going to be greater than this. And that is how you would graph and solve a linear inequality with two variables. Now our second choice, let's go over the second choice. It says you can use a test point. For example, 0, 0 to determine which side of the line to shade. What do I mean by this? All right. I'm going to use our origin here. 0, 0. Now in an ordered pair, your first value is x, your second value is y. So what does that tell me? I can take my inequality here and I can plug in these values and see if it works. So I'm going to use 0 for y. I'm going to use a little bit darker here too. And I'm going to use 0 for x and see if it works. Alright, so I used the values in my ordered pair and I plugged it in. Let's see what happens. 1/2 times 0 gives me 0. 0 plus 1 gives me 1. And when I solve this out, it's telling me 0 is greater than 1. Does that work here? No, it doesn't. 0 is not greater than 1. So that's telling me I couldn't use this point as a solution. Because that's what we're trying to figure out here. What's telling us is literally everything you shade is a solution to this. 0, 0 is not a solution. Since it's found beneath the line, then I can't use it. So what I'm going to do is I'm going to shade everything that is on the other side of this line here, which is why I shaded everything above it. So you have a couple choices here. You can use a test point to see if your test point works, or you can go with the method of where's y? Is it greater or is it less? This is a tricky process. So what I'm going to do is I'm going to do another problem or two with you. We'll walk through our steps. So let's try another one here. We're going to try, for an example, we'll do y is less than or equal to, let's go with 2/3 x, and you know what, we'll make it negative. We're going to go with a negative slope. It's good to have a negative slope in there every now and then. Plus, we'll say 3. Okay. So I'm going to graph that now on my graph. I'm going to make a nice little coordinate plane here. Now, in your cases, you're going to be provided these, but if you ever need to, you can just draw them out just like this. All right, now I'm going to walk through my steps. Step 1, get y alone. Is y all alone? It is. We're in good shape. Y is all alone. All right, step 1 done. Nice and easy. Step 2, graph your y-intercept. Okay, what's my y-intercept here? Let's take a look. +3. Okay, I'm going to go to my line. I'm going to go up 1, 2, 3. Going to graph 3 right here. Step 3. Use your graph to graph at least one more point. At least one more point. So I'm going to go, let's see, for my slope, let's take a look. I've got, ooh, did not want to do that. That's okay. Negative 2/3. Okay, so what does that tell me? First of all, we had some trouble with this last week, so it's good to see a negative slope. What I'm going to do first, I'm going to go down 2. I'm going to go over here. I'm going to do some purple. I'm going to go down 2. Come on. Down 2. And then over 1, 2, 3. And that's going to give me my next point. And I can do this a few times just to make sure I get a nice, good line out of it. Down 2, over 3. All right, so I've got 3 points here. I'm in pretty good shape. Now, here's the check we talked about last week. If your slope is negative, That means your line should be going downwards. If you look at this line, eventually when I connect these dots, they're going to be going down just like this. This is what I want to see. That's a negative slope. So I know I did this right. Now for my fourth step, which I kind of jumped to, I'm going to graph a line. And if my inequality is underlined, I use a solid line. If not, I use a dashed line. In this case, y is less than or equal to. You notice that it is underlined here. In this case, since it is underlined, I went with a solid line, and I just graphed it just like so. And now I am almost done. I am really close to being done. So now my last step, I have to shade using one of the methods below. I can use my y, or I can plug in a value. I'm going to go with both here. Let's see. Now, first of all, it's telling me that y is less. If it's telling me y is less than this, that means everything beneath is going to be my solution. So since y is less, right, it's telling me I can shade in everything underneath it. Now, some people really like this part. They're like, I like coloring. Coloring's good. It should be pretty solid, but you guys get the idea. That is using choice 1. Now, choice 2, what I could do is I like using my origin. I go with 0, 0. Why? Easy numbers, right? My ordered pair here is 0, 0. So what I'm going to do is I'm going to plug in those values here. For y, I'm going to plug in 0. For x, I'm going to plug in 0. And now our goal is to see, does it work? Negative 2/3 plus times 0 gives me 0. 0 plus 3 gives me 3. Now let's take a look at our solution here. 0 is less than or equal to 3. Is that true? Yeah, it certainly is. 0 is definitely less than 3. So that means that the origin here is part of my solution. So since I find 0, 0 beneath my line, I color everything beneath it just like I did. All right, so that's basically graphing and solving linear inequalities with two variables. Remember, there are some steps involved here. The steps again, get y alone, graph your y-intercept, use your slope to graph some points, you graph a line, and then you have to determine whether you shade in above or below that line. And you got a couple of choices. You can use a test point, or you can just say, okay, if y is greater, color above. If y is less, color below. And that is solving linear inequalities with two or more variables. We're going to give you some examples to practice.